Hi, this is the first video in the playlist where we're going to be looking at the Edexcel higher tier paper, and it's from November 2017. The plan is to work through the questions for about 25-30 minutes or so, give you the opportunity to then stop the video, have a go at each of the questions and then compare your solutions. Okay, so let's move on then to question number 1, which asks us to write 36 as a product of its prime factors. Okay, so prime numbers are numbers that are only divisible by themselves and 1, and a factor is a number that will divide into 36. I would generally tend to use a factor tree. Now the reason I use a factor tree is just because it makes it a little bit easier to kind of visualize, and as you can see, what I'm doing here is I'm creating this pattern of the actual factors on the left hand side. It sort of works for me. I think it's very neat and very easy way to do it. So the number 36 as a product of its prime factors is 2 times 2 times 3 times 3. If I just check that, we've got 2 times 2 is 4, 4 times 3 is 12, and 12 times 3 is 36. So that should be absolutely fine. Okay, let's move on then to question number 2. Question number 2 is one of those questions where you just need to do a little bit of algebra, and it says Kiara is 7 years older than Jay. Martha is twice as old as Kiara. The sum of their three ages is 77. All right, so let's start with writing this down. I think I would write something like J, K, and M. All righty, and then I'm just going to use the value of X for J because it doesn't give us actually any, 7 years older or twice as old. So I can use J as being the value X, which would mean that Kiara is going to be X plus 7 and Martha is going to be 2 times Kiara's age, which is X plus 7. Okay, and when we add all of that together, we're going to get the sum of their three ages, which is 77. Okay, so really we've now got an equation to solve. We've got X plus 7 plus 2 times X plus 7 equals 77. All right, and then it's really just a case of expanding the brackets and then solving for X. So I'm going to write this as X plus 7 plus 2X plus 14 equals 77. I tend to prefer to write everything out longhand because it helps me then just to work everything out properly. So I've got X plus 2X is going to be 4X. 7 plus 14 is going to be 21, and that's going to equal 77. If I minus 21 from both sides, I get 4x equals 56. Okay, I'm going to divide through by 4, and that's going to give me x equals 14. Okay, so at long last, I've got a value of J's age. Okay, so we can just write this out if you want, that J is 14. It would mean then that Kiara, who is 7 years older than Jay, is 21. And then finally Martha, who is twice as old as Kiara, is going to be 42. And if you add those three numbers together, you're going to get 77. Okay, however, it does say, well, we could leave it as the ratio, but there is a temptation there to kind of simplify the ratio a little bit. So I can divide through by 7 if I want to, and I can put this in the ratio of 2 to 3 to 6. Okay, doesn't really matter. It's absolutely fine. There is no mention that on the actual question. So I would imagine on the mark scheme you could leave it as 14 to 21 to 42. Okay, hope that's okay for you. Let's move on then to question number 3. Please do stop the video, have a go at this question, and then compare your solution. This is one of those, not always the most popular type of question because it's asking you to give a reason for each stage of your working, okay? And we're being asked to show that, and this is the important thing, show that angle ABF is 70 degrees, okay? So ABF is ABF. So we're actually showing that this is 70 degrees. Okay, so a couple of things we can start off with. I would actually say that angle AFB is 35 degrees, okay? Now the reason I would say that is because opposite angles are equal. So hopefully I'll be able to just write this on the video. I'm going to try to kind of give you as much space as I can, but angle AFB equals 35 degrees, and the reason I'd say that is that opposite angles are equal. Okay, so that'll be my first point. Okay, my next thing would be, I would say that angle BAF, so this is this one right at the very top here, is 75 degrees. Okay, now the reason I know that's 75 degrees is because opposite angles of a parallelogram are also equal. Okay, so I can write that angle BAF equals 75 degrees, and the reason that is the case is that opposite angles of parallelogram, okay, excuse my awful writing, but hopefully you'll be able to read it okay, or at least follow what I'm saying, and it's the parallelogram ABCD are equal. Okay, and basically then we can look at this triangle AFB, and because we know all the angles, all the internal angles in a triangle add up to 180 degrees, then we can kind of figure out then that that should be 70. So I'm just going to kind of write that out. Okay, so I know we've lost the picture, but hopefully it should be okay. I'm going to make a statement that AFB is a triangle. Okay, I'll put these three little dots, which means therefore all angles add to 180 degrees. Okay, well, we know that we've got angle AFB, which is 35. We know we've got BAF, which is 75. And then we've got angle ABF, which is the one that we're being asked to prove. Okay, so if we then work that out, we've got 110 plus angle ABF equals 180. So angle ABF must equal 70 degrees. Okay, and that would be absolutely fine for this type of question. Hopefully that'll give you some indication of the level of detail that they're looking for 4 marks. Okay, so let's move on then to another 4-mark question, which is question number 4. We're about halfway or so through the video. Please do stop, have a go at this one, okay, and see how you get on. All right. Again, this one, unfortunately, because it's on a full page, it's going to be a little bit, I'm going to have to move it around a little bit, but hopefully you'll be able to get the idea of what I'm doing. Please do download this paper, and then you'll be able to try it also for yourself. Okay. The thing about this is this particular word is exactly. Okay, Daisy says that exactly 1/3 of the logo is shaded. Okay, well, if 1/3 of the logo was shaded, then actually we'd be looking for 33.333% 0.3 recurring, so it'd be 33 1/3%. So that's the bit that we need to be a little bit careful of, because if we're trying to work out the area of the shaded bit, then what I'm going to do is I'm going to firstly work out the area of the central circle, then I'm going to work out the area of the whole circle, which is 7 centimeters, because if I take that away from that whole area, I'm going to get the area of the shaded bit. Okay, and then also I can work out the area of the absolute circle, which is actually 10 centimeters, 4 plus 3 plus 3. Okay, hopefully that won't be too complicated to follow, but you'll be able to follow what I'm doing here. So basically what I'm saying is I've got an area of the 4 centimeters circle, okay? Sorry, 4 centimeters, and that's going to equal pi r squared, so that's going to give me 16 pi. Now the reason that is because the radius is 4 centimetres, so 4 times 4 is 16, so that will give me 16 pi. Okay, I can do exactly the same for the area of the 7 centimetre circle, and that's going to give me pi r squared, which again is 7 times 7 is 49, and then pi. Okay, now at this point it is a non-calculator paper, so I'm not too worried about pi because I'm only going to use it, I'm actually only going to use the numbers to be able to work out my fractions. So let's finally finish off with the area of the 10 centimetre circle. And that's going to equal, again, pi r squared, so that's going to give me 10 times 10 is 100, so that's going to give me 100 pi. Okay, so we've got now the components in place to be able to answer this question, because we can work out the area of the shaded, okay, by taking the area of the 7 centimetre circle and then the 4 centimetre circle and then taking one away from the other. So we've actually got 49 pi minus 16 pi, so that's going to give us 33 pi. So we know now the area of the shaded is going to be 33 pi, which means that the fraction of the shaded, okay, is going to be 33 pi out of the overall circle, which is 100 pi. Okay, so if we work that out, that's going to, we knock off these pi's, and 33 out of 100 is 33%. Okay, now this is going back again to the original point, exactly 1/3. Okay, well, if it was 1/3, so if 1/3, it would equal 33.3 recurring percent. Okay, so actually in this particular case, because it's exactly 33% and not 33.3% recurring, then Daisy is incorrect. Okay, although it's fairly close. Okay, so let's have a look then at question number 5. I hope you've been okay with following the reasoning on question number 4. Let's move on a little bit. Okay, and we've got in question number 5, weekly earnings of 20 people in a shop, and we're being asked to work out the mean or the average, okay, mean or average of the weekly earnings. Okay, well, the easiest one with this is really to work out the frequency times the middle value. Now, I do get all sorts of different students saying different things about this, but basically what we're saying is we're assuming for each of these values in here that this one person has actually, although it says between 150 to 250 pounds weekly, we're assuming that that one person is average. So the mid value is 200, so they've actually earned 200 pounds. The same with the 11 people next, that actually we're assuming those 11 people make an average of 300 pounds each. Okay, so when we do mean, we're really doing these sorts of questions, we're actually doing the average of the average. Okay, so 11 times 300 is going to be 3,300. Okay, same with these 5 people here, we're assuming they all get 400 pounds, so that's going to be 2,000 pounds. Okay, nobody in there, and then these 3 people here, we're assuming that they all get 600. Okay, so that's going to be 1,800 pounds. Okay, if we add up all of that, it means the total bill is going to be 7,300 out of the 20 people who have earned salary in that particular week. Okay. Big shop. Okay, very big shop. All right, so let's have a look at then how we can use that information to work out the value of the mean. Well, the value of the mean, I tend to write it as total divided by number. Okay, because it kind of reminds me that I want the total earnings, 7,300, divided by 20. Okay. And that will give me then the average value. Now, there's a couple of ways in which you could do that. For me personally, I would reduce the fraction to 730 over 2, and then I would just do some short division. Okay, if I do some short division, that would work out at 365. So actually the average mean weekly earnings for this particular shop are going to be £365. Okay. All right, on to part B of this particular question. It says, Nadia says the mean may not be the best average to use to represent this information, and she's absolutely right actually, because the difficulty with the mean is affected by extreme values. Okay, so let's say you have one person in the shop, maybe the director of the shop or something like that, bearing in mind it's quite a big establishment by the looks of it, who's earning, say, £1,000 or £2,000 a week. Okay, well that's going to really affect the mean value. So normally in these sorts of circumstances, the median might be better. Okay, now it's up to you. You could actually put some figures into this. You could work out, if you wanted, the mean if you increased the total value of the weekly earnings from 7,300 to, say, I don't know, £9,000 or £10,000, and see what effect that would have just if one person earns a lot of money. Okay, hope that's all right for you. Let's move on then to question number 6. We are 16 minutes into the video, so please do have a go at this particular question. This is a good question really to gain 4 marks on. Okay, and it's using this whole idea that you've got a rectangle, and we're trying to find out, again, another show that question, and we're trying to find out, I'll show that y equals 3. Well, because it's a rectangle, we can actually say that this side and this side are equal to each other, and that's where we're going to start, because both of those contain x, and if they both contain x, that means we can solve for x. Okay, so we can say that 2x plus 6 equals 5x minus 9. Okay, and then really it's just a case of how you would now solve that. For me, I would take this 2x on the left and I would take it away and move it towards the right hand side. So I would minus 2x both sides, get rid of that, that becomes 6 equals 3x minus 9. Okay, and then what I'm going to do is I'm going to add 9 to both sides, so plus 9 and plus 9, so that's going to be 15 equals 3x. Divide by 3, so I can now finally calculate that x equals 5, and that's kind of useful for me because I can now plug this back into my measurements at the top here. Okay, and if I do that, if I say x equals 5, okay, then on the left hand side I've got 2 times x, which is going to be 10, plus 6, which is therefore that side is 16, and it also means that 5 times 5 is 25 minus 9, so that's 16 as well, which is great for me because now I know it definitely is a rectangle. Okay, so what we're being told then is that the area is 48 centimeters squared. Okay, well, area is going to be height times length, or however you would write this. So let's just plug in this type of information. Well, we know that the area is 48. Okay, we know the height is going to be 16 because we just worked it out, and the length, we're going to call it y because that's what we're being asked to solve. Okay, so in fact 48 equals 16y, and I can divide both sides by 16, which will give me then y equals 3. So I've actually answered that particular question and shown that y equals 3. I'll just move this up slightly so you can see that. Okay, I hope that's okay for you. It does take a little bit of thinking through and working out, but basically you're just trying to work out the value of x first and then show that the area calculation must have a value of 3 for y. Okay, that's 20 minutes into the video. We'll still keep going a little bit longer, and we'll just go to Brogan, who has drawn a graph of y equals x squared plus 1. What's the problem with the graph? Okay, so write down one thing that is wrong with Brogan's graph. Okay, well, because it's x squared, it's actually a quadratic. So quadratics are drawn as a smooth curve. So I'm just going to write it should be a smooth curve. Okay, so you can see what he's done is he's just drawn point to point as straight lines, but actually we're really looking for something that should be more like that. Okay, hope that's okay for you. Let's move on then to question number 8. Okay, write these numbers in order of size. Okay, I think in these circumstances, actually, I generally tend to write out the numbers and then just compare them. And I always write them out to a similar number of decimal places because it just gives me a much better idea. So if we look at the first one, we've got 0.2. I'm going to put 464646. Okay, that's fine. And then the next one, I've got 0.24. 666. So I've got 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. Okay, and then I've got 0.246246. Okay, and then 0.246000. 0 again. Okay, so we've all got the same number of decimal places. That allows me then just to compare them, and what I should get is 0.246, okay, followed closely by 0.246 with a repetition there, and then I've got 0.246 with a repetition above the 4 and the 6, and then lastly I've got 0.246 recurring. Okay, hope that's okay for you. That's just the way I do it. It seems to kind of work out okay for me with those sorts of questions. Okay, so we'll move on then to question number 9. We might stop the video after question number 10. We'll see how we get on with question number 9. Okay, so we've got James and Peter cycle on the same 50-kilometre route. Okay, and it took James 2.5 hours. Okay, why have they given us that information? Well, they've given us that information to be able to initially at least work out James's speed. Okay, so James's speed. So I'm not going to read even the rest of the question. I'm just going to look at James's speed equals distance divided by time. Okay, now you've got to be very careful here because we've got a distance of 50. But his time is 2.5 hours, okay? So if it's 2.5 hours, I could write it as 2.5, okay? Remember, you wouldn't write 2 hours and 30 minutes or 2.3. You could write 2 and then 3 out of 60, but we've got to remember there are 60 minutes and an hour, so it's quite tricky to make sure that this number is correct. Okay, now in this particular case I've just converted to a decimal of 0.5, so that would work out for me, and it means then that I can calculate that as 500 divided by 25 just by moving the decimal point. Okay, 50 divided by 25 is 2, so put a 0 on the end, so that's going to give me 20 kilometres per hour. You might slightly do it differently to me, but essentially, hopefully both of us will come up with the 20 kilometres per hour. Okay, now Peter caught up with James when they both cycled 15 kilometres. Okay, so we've got to look at that point. All right, so at 15 kilometres, okay, at 15 kilometres, James had taken 3/4 of an hour. Okay, and that's important. It's 45 minutes, okay? Because we're then told that Peter had actually set off 5 minutes after James. So it means at that point, Peter had taken 40 minutes. So Peter had taken 40 minutes, okay, and that's the important thing. So Peter's cycling slightly faster than James actually is. But now what we know is that he's gone a distance of 15 kilometres because that's where they met, and also he's taken 40 minutes to get there. So therefore it gives us the components to work out Peter's speed, which is what we're being asked to do. So Peter's speed is going to be the distance, which is 15, divided by the time it took. All right, now, as I mentioned before, you're going to be very careful. It's 40 minutes, which is effectively 40 out of 60, okay? So, hopefully that's okay for you, that we're working at the speed in kilometres per hour. So this bit here, which we know is 2/3 of an hour, we could write as 40 over 60, and that will allow us to perform the calculation. Because what we can say is that that's the same as saying 15 divided by 2/3, or if you prefer, 15 divided by 2/3. Now, 15 over 1 is exactly the same as 15, so we've got this situation now where we've created a division of fractions, so we can just do 15 over 1, multiply and flip, okay, which is going to give us 45 over 2, okay. Hopefully you're following my calculation here, that then Peter's speed is going to be equal to 22.5 kilometres per hour. All right, now I'm very aware I've kind of rushed through these sorts of things. I'm very used to working with fractions, so it kind of works out for me. But if you're not sure about any of these calculations, please do have a look at the channel, because there is a playlist on speed, distance and time type problems, and that will give you a little bit more time to work through them and try some other examples. Okay, so I think we will finish there. It's actually gone a little bit longer than I thought, and then from the next video we're going to start from question number 10. I hope it's been useful to you. Please do add a comment below. If you're not sure about anything, I'll always come back to you. Have a look on the channel and specifically the playlists, and they will give you some other examples as well, and I look forward to seeing you inside the next video.